Okay, hello, second and sixth periods. For some reason, I am having trouble getting anything to link to the school webpage. Excuse me. So I could not put your key on there. So I decided the easiest way to do this would be to make you a video of the key, excuse me, for the review we started on Wednesday, November 28th. So if you need to pause at any time, you can pause and look at a specific part of this. I really can't zoom in much on a video except by coming closer like this. Notice on 1A and 1B, remember that the domain and range of a linear equation are all real numbers, both. Okay, on C and D, I wanted to point out on these parts right here, those are both exponential, and I wanted to remind you that the domain of an exponential is always all real numbers. But I wanted to point out here, as well as on the back, I pointed out that these numbers, the range, should match these numbers here. In other words, whatever your f of x approaches for your end behavior, that should match the numbers you have for your range in interval notation. If this was not an interval notation, what it would say is y is greater than -4. And this one over here would say that y is less than 5 if it were not an interval notation. So if you got y is greater than -4 here, or y is less than 5 here, then you got the range correct, you just didn't write it in interval notation. But again, the range, the numbers for the range should also match these numbers here. In other words, what happens to the end behavior in terms of the y, or the f of x. That's the same thing as what the range is. Okay, so moving on. Did not worry about the even odd thing because we're just looking mainly at the parts of this that are possibly relevant to the performance final in terms of our topic list. Here is descriptions of transformations. Okay, and you do need to describe each one in words. Moving down, okay, right here, if you look at part B of number 5, and this is the nice thing about having a video is I can point something out to you. It said a horizontal shrink by a factor of 2. You would not have a horizontal shrink by a factor of 2. A shrink would be by a factor of 1/2. So if you have a horizontal shrink, then let's go ahead and say it's a factor of 1/2. Okay, remember that with horizontal, what you get is the opposite of, what you see is the opposite of what you get. In other words, if it's got a 2 here, when we talk about the factor, we flip it. We give the reciprocal of that 2. So if it has a 2 in the equation, that's going to be, and it's a 2, normally we think of a 2 as being something that would make it larger. Well, it's the opposite. It's a compression or shrink by a factor of the reciprocal of 2, which is 1/2. Okay, this was an oops, that closed parentheses should not be there because this -10 is also inside the parentheses. So it should just say -x minus 10 inside the parentheses. Moving on to the back here, look at the ones at the top. Just check those real quick. I did not go into the detail on number 6, but you should explain those in complete sentences. Can't do everything for you here. You're going to have to do some of it. Number 7. You could check your work on these. And of course it does say to explain why. And so I explained why I chose to do the method I did. I did both A and B by substitution because it seemed like the easiest way to do it for me for both of those. And both B and D by elimination. Okay, again, you can pause at any time, so I don't even know why I'm going kind of slowly for you, sorry. On number 8, you're going to have 2 equations. You have to have 2 equations to have a system of equations. One of them here is going to talk about what they paid for everything, what the cost is to them. The other one Yeah, I just noticed that. It says earrings, but without an extra ear. It's earnings. Sorry. Okay, just notice I left out the N. So this should say earnings. E-A-R-N-I-N-G-S. So one of the equations is about the cost and one of them is about what you earn. And so then you have this system and you can solve it using any method you want. Now looking down here in second period, we didn't read very carefully. This actually tells you that the horizontal asymptote is 4. We talked in second period about how hard it was to see, and we decided we were just going to proclaim it to be 1. So these are the answers for having a horizontal asymptote of 1. So I went ahead and stuck with that model. Horizontal asymptote of 1, these are what your answers would be. It actually says the horizontal asymptote is 4, and we talked about that 6th period. So for 6th period, every time you see a 1, you change it to a 4. This is a 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4. So that also kind of helps you see how the horizontal asymptote is so integral in behavior, domain, and range, and where it comes from in the equation. And again, I pointed out here, notice that your range always comes from what my f of x is approaching. Okay, range goes with the y values, and f of x is another way of saying y. So if f of x is approaching negative infinity on one end and positive 1 on the other, that means my y values range from negative infinity to 1. And that is all.